Hey everybody, this is your chapter 3 overview. Let me go ahead and share the screen. There we go. Okay, and let me go ahead. Chapter 3, I'm gonna go ahead and launch it. There you go. Okay, so let's take a look at what's in chapter 3, infrastructure and client devices with wireless networking. Okay, so we have a lot of what this chapter is about is wireless access points. Okay, there are different types of access point, the autonomous ones, kind of like what we might use at home. Okay, there are ones that are controller managed for larger local area networks, and then we have cloud managements, which can then be accessed, anywhere in the world. Okay, so it really has to do with where you control it and where you have to access into it, and then how sophisticated the device is, and then the features that make it capable at that level. So an autonomous one are really centered around what you and I do at home. So let's take a look at this. Well, first of all, we have to know a little bit about communications. We have things like duplex, half duplex, full duplex, okay? When we talk about half duplex communications, it's kind of like a walkie-talkie radio. It's where I talk, you listen, you talk, I listen, and so we got to take turns. And so understanding a little bit about that, that plays a role in the effectiveness. It takes a role in the lag and the speed of what's communicating between our devices, our access points, and our devices at the other end. Okay, an access point, we might see something like here, a broadband router and stuff. This one here, it says it's gigabit. Okay, great. USB 2.0 seems a little bit old, right? Probably should have been, maybe by today's standard, should be 4.0, whichever. Okay, power, and then an internet connection port for your wired connections. Okay, the consumer grade ones and stuff would deal with NAT. Okay, network address translation. So we talked about that in an earlier chapter. DHCP, where your router has the ability to say, hey, any devices that talk, whether it's wired or wireless at home, we're going to assign a dynamic IP address for that device, so this way they can talk. So when I'm on my cell phone, I usually use cellular technology. But when I say, hey, I'm going to switch from cellular to my home Wi-Fi, then my Wi-Fi needs to be able to, my router needs to be able to talk to my phone, and there needs to be an IP address assigned so we can create our session and we can talk back and forth. And so DHCP happens on them, okay? I'm having such a small network, I don't need to have a statically assigned IP address to each of my devices. The DHCP, the temporary device, is more than sufficient. We even do DHCP here on this campus in a large way. We have some devices which have static IP addresses, but many, like in a computer lab, we'll use DHCP to say, hey, when a person wants to go out to the internet, it gets a license to be able to use it, and then we could recycle that over and over again. And so we don't have to account for every IP address as we do for a static one, okay? IP protocol routing DNS for names, so we can have names for things, just like we have www.fresnocitycollege.edu, and then we have the IP address for it as well, okay? As well as built-in firewalls. Back to the small office, home office, again, depending upon your brand, there are enterprise grade ones and the consumer ones that we have. Sometimes you say, hey, is it a D-Link? Is it a Cisco router? Is it a Linksys, which is a little baby sister of Cisco? It just depends on, what you like and what brand, Netgear or whatever. A lot of these and stuff, the communications, we have antennas that we can remove, but actually kind of remove them on a lot of them today, so that's not really good distinguishing whatever. They have a static output and stuff or power. They have advanced security operations, absolutely, in configuration, and they typically can act as a DHCP server, handing out those options, okay? You would use, just like with here, you would use some kind of browser base. And so when I'm doing my browser, sometimes they'll tell you that, hey, you want to get to the browser, to that router, the manufacturer D-Link will have an IP address assigned. So instead of typing in the address on the address bar line, you'll type in the IP address, which will take you to a login screen so you can then do your wireless configurations here, okay? Enterprise ones, a little bit more sophisticated access points on a larger scale. So, we may use something that has more features to be able to handle this deployment. And again, you could have something like Ubiquiti or whatever, that does it. So I've used them as well, and try to cover this campus. Or again, the school may tie on an even more sophisticated, more expensive, because they have so many to deploy. But again, there's that enterprise grade Okay, again, these are still, everything's still in the wireless using 802.11 standards, whatever they may be. Going to have a Wi-Fi certification, so probably, Wi-Fi 6, whatever. We get an antenna removal, that's not really a big deal, whatever. Multiple operations, we can handle things like as a bridge or a repeater, okay. Does it have a graphical interface, and also does it have a command line interface? Those of you who have taken my 40 class understand the difference between those two. Okay, and then there's the cloud managed access points. Okay, again, it's sometimes it's I can log into my Linksys router account anywhere in the world and change the configuration to my Linksys router at home. Okay, or the same thing with Ubiquity. I could be anywhere in the world, and if I'm using Ubiquity at my office or whatever, or my buildings that I own, I can access the software from the cloud and send and exchange and change settings or whatever remotely, okay, from a cloud technology. Okay. Anyway, in that process, again, a little redundancy here in this chapter about wireless mesh communicating back and forth with various access points. Okay, and so that mesh technology, again, where do we have the overlap and stuff? We have that overlap, like on, again, a campus or whatever. You and I might use something like a Google Mesh or something like that. I mean, there's something that we can do in our house, right, where we have various devices, access points that talk to each other, and we create this overlapping field. So wherever we're navigating through our house, okay, we always should have a sufficient signal to be able to handle that communications. And we're really just bogged down by the bandwidth or the speed of the device, okay, or how much we're paying for our internet access, okay? Again, larger examples could also be transportations, big venues. Again, I put in big venue like a location like our parking lots here at school. I think every parking lot should be covered. And that's one of those ones that sometimes are left off, okay? I tell people, it's like, how many, you get a couple hundred cars in the, in the parking area or whatever. Well, times 1 or 2 students, that's a couple hundred people. That's a pretty good amount of people. We're not talking about a couple hundred people at your house, right? Kind of thing. So just something to think about that. And then it's going to talk about things like wireless bridges, okay? And there's what we call bridges, and then what we call gateways, okay? This here, it says, oh, okay, 2 or more wireless LANs. Well, that is not exactly the true definition of the word bridge, okay? So I'm going to jump over here real quick. So what's the difference between, say, a bridge and a gateway, okay? So a bridge and a gateway. Got it. Okay. They are basically what we use to connect networks. So we could look at saying, hey, a basic bridge transmits the frames between 2 separated segments of LAN. And a gateway is a protocol converter. Okay. This one operates on 2 layers, the physical and data link. The gateway operates on all 7 layers. Okay, how about a visual here? Here we go. All right, so take a look at this bridge here, okay, between 2 different networks here, okay? When we look at our communications, and here's a gateway, okay? What we're gonna find is that typically when we look at bridges, we look at the communications between 2 different types of networks. So a wired network talking to a wireless network. So let's come back over here to the screen here. There we go. So we have a wired network going to an access point, and then the signal around this access point may not be strong. So we have a repeater, or like an extender, that our wireless client can then talk to. It can't reach all the way to the access point, but it can reach to the point over here and then send the signal back and forth, okay? And so when we look at those kind of controllers and those devices, what's the wireless bridge is to talk to 2 different types of protocols, right? The wired network talking to the wireless network. What's a gateway? 2 of the same protocols talking to each other. Network segment A versus network segment B talking to each other. I need a gateway to help me assist in that communications. If they're 2 different types of networks and stuff, wired versus wireless, then I have a bridge. There used to be all these were all separate to physical devices. Nowadays, typically your router has all the capabilities and takes care of it yourself. Okay, that's where you get kind of a better system. The last thing that the chapter talks about was power over the Ethernet. It's kind of was a drop into this chapter. I'm not sure the concept, because again, it gets back to our wireless, but let's think about it. Just take it for a simple topic for what it is. Power over the Ethernet. We have Ethernet cables. Okay, so we have the cable that goes across our Ethernet that we plug in the back of our computers. Now, typically we run that to an access point. But where is that access point going to be? Okay, it could be, you know, out by the garage, or it can be down, you know, the other side of the house or whatever. Is there power at that location? Another example, a security camera. I want to put a security camera over the driveway. Well, do I have power over the driveway? Okay, does that mean I have to run electricity all the way out to that camera and run the data cable all the way out to that camera? Traditionally, the answer would be yeah. But now what we could do is we could just run the cable, the data cable, all the way out to the camera, and it uses the wires, a couple of the wires in the Ethernet cable, to send a trickle power source to that antenna. And what does that do? It allows it to then, to that camera. So it allows it to what? Power up that security camera. So power over the Ethernet and stuff is a pretty common thing nowadays, okay? Especially with cameras, you got to make sure the devices can support the power voltage on it, okay? So you have to look at those numbers. But hey, in the long run, it's saving me from having to run a separate electrician, a separate electrical place. Now, some people will say, well, I don't need PoE because I have a battery operated security camera. Hey, that's right. You don't need power because your battery, but how long does the battery last? And then how often are you going to have to recharge that battery and or replace that battery? Yeah, PoE is probably a lot better. Okay, so certainly if you have the power source to be able to power the camera there, fantastic, you've got the power. And whether it's a camera, whether it's an access point, whether it's a repeater or extenders or whatever, it's a different way of doing it. Okay, so power over the Ethernet, looking at that, basically has its own device, okay, that we would plug into, and then this would send electrical currents through those lines. Okay, so just because it's a cable and just an Ethernet cable or whatever doesn't mean that it is the right cable and stuff that you'll be using for PoE switches. Okay, so you need a power over Ethernet switches if you're going to send the power. Okay, and so keep that in mind. Again, what we're talking about doing here is a bridge between a wired connection and a wireless one. So we need to be able to talk wireless in between here. So we need a bridge device to be able to do that. So hopefully that gives you a kind of a good understanding of chapter 3 as you read through. All right, let me go ahead and stop this to share, and we'll end the recording, and you have a great one, and we'll see you in the next video.